So, very good morning to all in one. Welcome for the lecture number 9 of particularly petroleum refining technology. So, in physical classes, we have studied about particularly unit 2 pre-refining and distillation. In that, we have seen what is the desalting process, moisture removal, then how to store that particular crude oils. Okay, and we are not seen what kind of this one, and we also studied the atmospheric distillation. Okay, so in today's class, we are going to learn about particularly, especially with the heat exchangers and pipe steel heaters, how these are used for storing that particulars, and then we will learn about the vacuum distillation for that. Okay, so first of all, let me share my screen for this one. Okay, okay, I hope the screen is visible to you for that. So next concept is about heating through particularly heat exchangers, pipe steel heaters. So n number of heat exchangers can be used, as we have studied various kind of heat exchangers like a double pipe heat exchanger, okay, shell and tube heat exchanger, U-tube type of heat exchanger. All these kinds of heat exchangers can be also used for, especially for heating of the crude oil at its required up to boiling point temperature. So here we can see that particularly we have the hot fluid, that is a double pipe heat exchanger. So when the double pipe heat exchanger is to be used, then co-current type of the fluid must be maintained across this. So this is again, it depends upon the number of passes, how the number of passes that can be increased with that particular regions. So this is about that. Second type of the figure, here it is a shell and tube heat exchanger, where counter current two pass heat exchangers can be also used. So in this shell and tube heat exchanger, you can see there are two pass kind of heat exchanger, and so can be preferred for that. Next is nothing but the shell and tube heat exchanger. Okay, if we have to use one pass exchanger, that is one pass on shell side and one pass on tube side, then co-current, okay, flow can be also maintained within this shell and tube heat exchanger. Now next is the shell and tube heat exchanger, which is flows in co-current manner. Okay, co-current flow can be also maintained, where exchangers will have two passes on shell side and one passes on tube side. So that can be also maintained in that particular regions of that. So these are the heating through the heat exchangers. Another type of heat exchanger is nothing but various kinds of the exchangers. That is, we have studied earlier, that is flange type of heat exchanger, then flanged end type of exchanger. Another one is the floating head type of the exchangers. Okay, another is the floating head type of the exchanger. These are utilized under this one. So these are the heat exchangers and pipe steel furnaces that can be used. So here you can see the tubes are attached to the tube sheet, right? So tubes are fixed within this particular tube sheets. These are going to be maintained in this particular areas. Okay, this was the flanged end. Okay, so even it depends upon which type of crude oil which we are going to handle. Choice depends upon the application, then range of viscosity and range of density of that particular fluid. Another common type which can be used, that is U-tube type of heat exchangers, where tubes are arranged in the form of bundles. So this is mostly commonly employed kind of heat exchangers in case of particularly, especially in case what we call as petroleum products. Okay, for petroleum products, these are well equipped products. These are going to be mentioned across that. Okay, so these are the various kind of heat exchangers. Now come to the next part. What is the heat balance? Okay, already we know that the heat balance across the heat exchangers which are going to be used, the heat balance depends upon the basic rule, that is the heat gained by one of the fluid is equal to heat lost by one of the fluid. So obviously cold fluid is going to gain the heat, okay, by cooling the heat, by cooling the hot fluid, and hot fluid is going to lose the heat. Okay, so if the inlet temperatures of the cold and hot fluids are suppose Tc1 Th1 and exit temperatures are Tc2 Th2, then the heat balance equation for sensible heat, if it is transferred If the sensible heat is transferred, then the equation we know that Q is equal to m dot Cp delta T, that is Th1 minus Thu or Tc2 minus Tc1. So heat gained by one fluid, okay, that is I can say heat here. Likewise, I can write heat gained by one of the fluid or heat lost by hot fluid is equal to heat lost by or heat gain by the cold fluid. Okay, so WH CPH TH1 minus TP2 is equal to WC CPC TC2 minus TC1 across this. So always knows that heat flows from the hot fluid through the film of the hot fluid, and then it enters into the wall of the tube wall, and then it goes through the film of the cold fluid. So always when any fluid flows through the exchangers and heat is applied from surrounding, first of all heat will be transferred to the wall and then from wall to the fluid. Thus, therefore, the heat flow takes place through a series of resistances where heat may flows by conduction, convection, especially majority the convection through the fluid films, by conduction through the metal wall thickness, and the overall heat transfer coefficient is calculated as U, okay, by taking into account that all the effects of three resistances are taken into considerations. Okay, all the three effects are taken under that consideration that will be covered within this particular session. Let us see the example over this. Okay, now this is the example for a particular crude oil. You can note it down. Okay, so right, crude oil is at a temperature of 135 degrees Celsius. See what is mentioned in the problem statement, having API of 35 degrees. So the API is most important property based on these particular considerations. Okay, so crude oil of temperature 135 degrees Celsius having an API of 35 is to be preheated at the rate of 20 tons per hour. Okay, so 20 tons per hour is a mass flow rate for the crude oil. I think the crude oil has to be heated, so it is a cold oil with a kerosene. Okay, so crude oil itself is a particularly cold fluid here. With a kerosene circulating reflux available from a crude distillation unit at a temperature of 200 degrees Celsius and at the rate of 290 kg per hour, 2904 kg per hour. So in this unit, we are able to see that this crude oil, we have to heat it using the hot fluid, that is the kerosene, which is available at 200 degrees Celsius at the rate of particularly 2904 kg per hour. So this is m dot h, mass flow rate of hot fluid, and mass flow rate of cold fluid was 20 tons per hour. If the exit temperatures of the kerosene and crude oil, so TC1 and TC2 is given, TCH and TC cold fluid, okay, that is given as 150 degrees Celsius respectively. Determine what will be the with total outer tube surface of 13.5 meters square, and counter current operation and the specific heat of the crude oil and kerosene at average temperature is given as 0.53 and 0.79 kilocalorie per kg degree Celsius. Okay, so that is going to be given as per that. Okay, so this is given as per this particular values, 0.53 and 0.79 kilocalorie per kg degree Celsius respectively, that is given. Okay, so this value is of CPC, specific heat for crude oil, and this is CPH, that is for